So hello, I am Jonathan Mendoza and I would be discussing about shearing stress. I'm from MEC32 E03. So shearing stress is produced whenever the applied load causes one section of a body to tend to slide past its adjacent section. So shear stress equals to shear force over area. In this figure, the rivet resists shear across its cross-sectional area, and this is a single shear. In this figure, it is a double shear due to having two cross-sectional areas in this area. So the shear force here is equals to P over 2. This is a circular slug. It's about to punch out a plate. This is the area which is pi dt. So example number 1 is a hole is to be punched out of a plate having an ultimate shearing stress of 300 megapascals. If the compressive stress in the punch is limited to 400 megapascals, A. Determine the maximum thickness of the plate from which a hole of 100 mm in diameter can be punched. If the plate is 10 mm thick, compute the smallest diameter hole that can be punched. So this is the given, which is the shear stress is equal to 300 MPa, and this is the compressive stress, which is 400 MPa. So for A, the thickness is the one required and diameter is given. So shear stress is equals to shear force over area, which is equals to shear force over pi dt. And this is the compressive stress equals to force over area, and the given 400 Newton millimeter squared is equals to P over pi dt, and you will get the P which is equals to 3.14 times 10 to the 6 Newton, which is also equal to the shear force. Therefore, shear force equals to 3.14 times 10 to the 6 Newton as well. And now, let's go back to the formula of the shear stress, which is equals to shear force over area. So, the given 300 Newton millimeter squared is equals to 3.14 times 10 to the 6 over pi dt. So, in here, you can get the thickness if you substitute it properly, which is equals to 33.33 millimeters. For letter B, thickness is given and the required is the diameter. So the same formulas for compressive stress, which is force over area, which is you will substitute it to get the P or the force, which is equals to 400 Newton millimeter squared times pi d squared over 4. So in here, after substituting, P is equals to 100 pi d squared. So P is equals to V, so V is equals to 100 pi d squared as well. So let's go back to the formula of shear stress, which is equals to shear force over area. So in here, substitute 300 Newton millimeter squared to the shear stress, which is equals to 100 pi d squared over pi dt. After substituting, we will get the diameter, which is equals to 30 millimeters. So for example number 2, the end cord of a timber truss is framed into the bottom cord as shown in the figure. Neglecting friction, compute the dimension B if the allowable shearing stress is 900 kilopascals. So in here is 150 mm, and this is B, which is what we will compute, and this is the shearing stress, which is 50 kilonewton. I mean, this is the P, or force, which is 50 kilonewton, and there is an angle which is 30 degrees. So shearing stress equals to shearing force over area. So in here, the V, or shearing force, equals to 50 kilonewton cosine 30 degrees, which is 43.3 kilonewton. So upon substituting, which is the stress is 900 kilopascals, we will convert it to Newton millimeter squared, which will be 0.9 Newton millimeter squared, is equals to 43.3 times 10 to the 6 Newton, which is V, over 150 mm times B. So that 150 mm times B is the area. So the B is the one required. So upon substituting in this one, these formulas, B is equals to 320.75 millimeters. So for example number 3, the bell crank shown is in equilibrium. Determine the required diameter of the connecting rod AB if its axial stress is limited to 100 megapascals. So in here, the axial stress is 100 MPa, and the required is the diameter of the connecting rod AB. So this distance, this is the distance, and this is the distance. We've got two given, which is C, force at C, and force at P. So compressive stress equals to P over area of AB. So first we need to get the moment at D, which is equals to 30 kilonewtons sine 60 degrees, which equals to 25.98 times 240 mm. This is the distance, 240 mm. Minus P, here this one, times 200 mm, which is the distance, is equals to 0. So we will get P, which is 31.18 kilonewtons. So going back to the formula, the shearing, the axial stress is equals to 100 Newton millimeter squared, is equals to 31.18 times 10 to the 3 Newton over pi d squared over 4. We will get the diameter, which is 19.92 millimeters, or equals to 20 millimeters. So that is all for the lesson in shearing stress. Thank you.